Hi, today we're going to go over some Taylor polynomial type of questions, and I just want to go over a couple of questions from the homework. And these are questions that are very similar to what you will see on the AP test. So for question number 7, it asks us to find a seventh degree Maclaurin approximation for sine of x. Well, remember, Maclaurin says that the center is 0. So we're going to need a bunch of zeros. So the zeroth derivative is just going to be our sine of x. The first derivative is cosine of x. The second derivative is going to be negative sine of x. The third derivative, of course, is going to give us, what's that going to give us here? Negative cosine of x. The fourth derivative is going to give us sine of x. The fifth derivative is going to give us cosine of x. And we want a seventh degree, so we got to take 7 derivatives. So the sixth derivative is going to be negative sine of x. And of course, the seventh derivative is cosine of x. Now it's Maclaurin, so now we're going to find the values of each of these at 0. Of course, sine of 0 is 0. Cosine of 0 is 1. We get 0. We get negative 1, 0. This becomes 1, 0, and negative 1 for us. Sorry about that, negative 1. Now remember, we're only interested in the ones that are not 0. Everything else just goes away, so we really don't need those. So when we build our seventh degree Taylor polynomial, so p sub 7 of x, we're going to get the following. Remember that p sub 7, this is saying that this is the seventh degree Taylor polynomial. Now remember, some books will use the letter T. That's okay. I like to use the letter P. When we write our polynomial, we would normally, we're going to use our Taylor, which is this Fn of C over n factorial x minus the center to the nth. Typically, we would start at n equals 0. However, n equals 0 gave us a 0, so we really don't have to worry about it. And if you notice, we really only have to worry about the ones that were odd. Those are the only ones that gave us values. So instead of starting at n equals 1, 0, we start at n equals 1. And this, of course, becomes 1 over 1 factorial, x minus 0 to the first. Don't worry about n equals 2, go straight to n equals 3. That becomes a minus 1 over 3 factorial, x minus 0 cubed. And then go to n equals 5. My coefficient, top of my coefficient is 1. That becomes plus 1 over 5 factorial, x minus 0 to the fifth. And then the last one we have to do, of course, is the 7. Again, we don't have to worry about the 6 because it just went away. Ran out of room, so I'll make this minus 1 over 7 factorial, x minus 0 to the 7th. Now, I kind of ran out of room here, so I'm going to blow this up here. We can clean up a lot of this, and I'm going to write my answer up here, so I apologize for that. So our seventh degree Taylor polynomial will just be x minus, what's that? X cubed over 3 factorial becomes plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial. And there is our Taylor polynomial, simplified. Now for part B is an interesting question. This one is a really tough one, and a lot of students, myself included, have misread this question. It says it's a two-parter. Use your approximation to approximate the value of this integral. So we're just going to set up this integral using our new Taylor. We're going to go from 0 to 1. Instead of using sine, instead of using the sine of t, we're going to use our polynomial. Now notice, they replaced each x with t, and that's easy to do. We can do that here. We're going to get t minus t cubed over 3 factorial plus t to the fifth over 5 factorial minus t to the seventh over 7 factorial all over t dt. And we're going to get this. When we simplify it, we get 0 to 1. This becomes 1 minus t squared over 3 factorial plus t to the fourth over 5 factorial minus t to the sixth over 7 factorial dt. And now I could integrate that. We're going to get t minus t cubed over 3 times 3 factorial plus t to the 5th over 5 times 5 factorial minus t to the 7th over 7 times 7 factorial. And we can evaluate that from 0 to 1. With our FTC, by plugging the 0, that's going to mean nothing for us. We don't really have to worry about that. Just plug in the 1, and we get for our final answer 1 minus 1 over 3 times 3 to the factorial plus 1 over 5 times 5 factorial. Now, I'm going to stop here for now because now I'm going to read the next of it. This next part says, so that the error in our approximation is less than 1 over 500. Well, if you notice, this is an alternating series. So what we're saying here is we want our error, that r sub n, to be less than 1 over 500. So in other words, that's our next term. We can stop there. There's our next term. So what that's telling me I can do here is if I look here, we're taking 1 minus, this is 1 over 3 times 3 factorial. That's just, what's that, 1 over 27? Nope, 1 over 18. Sorry about that. But this part right over here, this is 5 times 5 factorial. Well, the bottom here is just 5 times 120. Well, that's 600. So this term right here is already less than 1 over 500. I can stop here. I don't have to go any further. So now because this term is less than what the error is asking for, I only have to go out 2 terms. So we would now say, because this is an alternating series, we have to use our mantra. The series alternates, decreases in magnitude, and the limit equals 0. Therefore, the integral 0 to 1 sine of t over t dt is about 1 minus 1 over 3 times 3 factorial. With an error, and we're going to say our error this way, r sub n is less than my next term, 1 over 600, which is less than that 1 over 500, which they're asking for, by the alternating series remainder. It seems like a lot, and there are shorter ways to write it, but you have to have all that in. Because it's alternating series, you have to mention that. We should always mention at the beginning. Anytime they say an approximation lesson, just mention that at the beginning. And you have to have your approximation to only 2 terms, and then you have to mention what the error, that the error is less than 600. All right, now for the next part, they just want us to use a calculator. Now they say, calculate the actual error in the found. Now this, I don't have my calculator with me, but you can do this. To get the error, this is going to be the actual value minus the approximate value. So for this one, we would have to use our calculator, 0 to 1, sine of t over t dt, minus this 1 minus 1 over 3 times 3 factorial. And that's going to give us our answer there. I don't have my calculator and I forget what it equals, but that's going to give you your approximate value right there. All right, I hope you guys enjoyed the video. I will see you all later.